Hello and welcome to the latest Counterpoint webinar, where we're going to talk about one of the biggest pain points that smartphone users experience, and that's battery life. Now, last week, I think, was International Battery Day, and we wanted to mark the occasion by getting into some of the specifics around what drives battery performance in smartphones, digging into all that's good about that. Now, one of the often repeated sayings is that we have Moore's law for semiconductors, but Moore's law doesn't apply to batteries. Now, the implication of that is that as the brains of your smartphone or computer get better and do so at a fairly specific rate, that batteries don't keep pace. So is that true? Well, let's find out. So to explore this, we have an illustrious panel that we've gathered together. So from Dxomark, the company that tests many aspects of consumer electronics, including smartphones, I'm delighted to welcome an old friend of Counterpoint's, Olivier Simon. Now, Olivier wears a couple of hats at Dxomark. He's the deputy CTO, but he also looks after a relatively new stream of testing for Dxomark, which looks specifically at batteries. We had a good discussion around this topic a few weeks ago on a podcast, which you can find on our website. And then representing the smartphone manufacturers, I'm excited to welcome Partha Nayak from Xiaomi. He's the Associate Director of Smartphones at Xiaomi in India. Now, Partha has a long career in various aspects of product management for a number of different companies, and he will have had to have battled with the various demands for battery performance trade-offs during that time. So I'm sure he can bring an interesting perspective there. Then from Qualcomm, we're delighted to welcome Josh Warner, who's Director of Product Management for their Quick Charge solution. And last but by no means least, we're excited to welcome Craig Weish, who's VP of Business Development from a company called Sila. Now, Sila is developing new battery chemistries that promise to bring some sort of revolution to the way that battery performance works within smartphones and other connected devices. So very excited to hear what Sila has to say on this topic. But before we welcome our first speaker, I wanted to just set the scene with some reflections of some of the research that we've been doing at Counterpoint. So I have a few slides which we'll just quickly run through that hopefully will just give you some insights into how the consumers see it, and then what we're seeing in terms of the way that battery performance is developing. So let me bring up the first chart here. So this first chart looks at the purchase decisions, what drives purchase decisions in smartphones. This comes from some consumer research that we did in India last year. And while this is specific to India, when we've done similar sorts of consumer research in other countries around the world, we see a lot of overlap. There's, consumers in different parts of the world have very similar experiences and similar requirements. So you can see at the top of the list in terms of what drives consumer purchase is battery life. So this is clearly an issue that people are concerned about. It's a perennial pain point, if we can put it like that. And I think we all know why. I mean, I think pretty much everyone has experienced that seed of doubt which arises during a busy day when you notice that your battery indicator is looking a bit low, and you're then doing a bit of mental calculation, figuring how long it will be before you're able to plug in and start to recharge the battery. But if we look further down the list of factors driving purchase decisions, we can see things like 5G, full display, having the latest processor. Now, some of these also drive greater consumption of battery power. 5G, although not a big driver of current drain, does enable the smartphone to do more. And over particularly in the last couple of years with the COVID pandemic, we have seen people doing more and more with their phones. And one of the areas that we have seen a lot of development is in the display technology. So we see larger displays with greater pixel density and faster refresh rates. Now, these do or can have an impact on the battery drain. And the smartphone makers have responded to this increase in usage and performance. So if we jump to the next slide, you can see how battery capacities have changed over time. Now, we separated out Android from Apple, and I'll show the Apple slide in a second. But within Android, you can see a very clear trend where more and more battery capacity is being added. So the sweet spot has now become 5,000 to 6,000 milliampere hours, or at least it was in the fourth quarter. Or also, if you look at the blue bar at the top here, albeit it's not very big, but there's now a number of products in the market with greater than 6,000 milliampere hour batteries. If we look at Apple, we see a similar trend, albeit that it's slightly different. And this is because Apple has changed the capacity of some of its iPhone batteries. So the iPhone 11 had a slightly larger battery than the iPhone 12, which is why the green bar sort of shrinks and then expands again as we move to iPhone 13, which has again moved to a larger battery. And also with iPhone 13 in the Pro Max, we're now seeing greater than 4,000 milliampere hour batteries for the first time with Apple. What we've also seen with smartphone makers over the last couple of years is a trend towards faster recharging. So on the one hand, you have batteries which are getting bigger in size, but also smartphone makers are provisioning more and more the ability to recharge batteries very quickly, sometimes from a flat battery to a full battery in almost a matter of minutes. So this is quite a remarkable change, and we'll hear more about that from our panelists. So let me stop here with the slides, and we'll get into the panel discussion. And first up, I'm delighted, as I say, to welcome Olivier Simon from Dxomark. Now, Olivier is going to run us through the testing protocols that Dxomark undertake in their battery testing service, and can give us some context around the particular scoring which they do across 3 key elements. So, Olivier, over to you.
Thank you very much. Hi, everyone. Yeah, so I'm Olivier Simon. I'm the Deputy CTO and leader of our battery team at Dxomark. First of all, I'll come back a bit on who exactly we are at Dxomark. So we're an independent test lab based in Paris. We are committed to develop test protocols to measure the quality of user experience. We develop our own labs, we sell our labs as well as testing services and benchmarks to drive the industry for a better user experience. So historically, we started with image quality on sensors, lens, cameras, both front and back on smartphones. And we expanded with smartphone audio, display, and recently battery. We're also the editor of Dxomark.com, designed to guide people in the choice of their next device. Recently, we have updated our website with a fresh look and feel. So I encourage you to visit this new Dxomark.com. So today, our focus is with battery, which is our latest Dxomark score, introduced about 10 months ago, back in May 2021. So how do we design a new score? At Dxomark, our philosophy is always the same. We start by analyzing the end user. We identify his expectations, his usages and habits, but also identify his concerns and pain points. Based on these observations, we then develop an extensive protocol to measure these usages and answer these concerns. Finally, we summarize all our measurements in a global score that allows to easily rank and compare devices. But we also, in the case of battery, we also bring direct and straightforward information to the end user, such as the autonomy you can expect on a full battery, as well as the charging time, for example. So this is a quick photo of our lab, which is the home of our robots. It's a Faraday cage to isolate all the devices under test from any external disturbance. Inside the cage, a network repeater and a Wi-Fi access point provide stable network conditions. The lighting conditions are also controlled. Measuring a device can take up to 150 hours of charging and discharging the phone and represents 70 measurements. Out of those 70 measurements, 30 of them are autonomy measurements, which we combine with battery capacity to calculate the current drains. The current drain is the speed at which your batteries drain in a specific use. So overall, that accounts for 100 parameters, which all are taken into account into our scoring system. So first, our test plan. So how do we test battery? We've designed 4 test plans. The first one is we call typical usage scenario. It's done by the robots inside the cage. And those robots are using the phone just as you and me by doing some clicks and swipes on the touch panel of the device. The typical usage scenario is a scenario that mimics a typical day in the life of an average user. So an average user is not you or me or my kids. It's the average usage worldwide reported with 4 hours of usage per day. So the scenario starts at 7 a.m. And throughout the day, the robots will watch movies, play games, make phone calls, check their social apps. And at 11 p.m., they stop having for the night. And the next morning, they will start the exact same routine again. That first test plans will provide, and of course, this will last until the battery dies, right? So this first test plan will provide us with the autonomy you can expect on a full battery when you're an average user. Of course, mobile phones are mobile, so we complement those tests with outdoor mobility tests on a predefined route where we will measure the autonomy you can expect for typical usages of the end user when they're on the go, like shooting photos and videos, making phone calls, using GPS navigation, and again, checking their social apps. We then go back in the Faraday cage, and here we will measure each and every possible use of a smartphone. We'll measure the autonomy you can expect, making phone calls, making streaming video in Wi-Fi, in cellular, doing video playback, playing games, and checking social apps. So each and every possible use of a smartphone will be measured individually. And this time, compared to the other 2 test plans, we will calibrate the device. We will calibrate the settings of the device and not measure the factory default settings. So calibrating the settings means we will calibrate the screen brightness to 200 nits. We will calibrate the sound pressure level of the speakers to 60 dB at 10 centimeter. We will freeze the refresh rate to 60 hertz so that we are in a position to measure all devices when they provide an equivalent user experience. So those are our autonomy measurements. And of course, we have another test plan to evaluate the charging experience. So of course, here we will measure the time it takes to charge from a fully depleted battery to a fully charged battery. But it's not really a typical user behavior. Usually we'll tend to plug our device before it powers down. So we complement these test plans with quick 5-minute power top-ups at different state of the battery when the indicator shows 20, 40, 60%. And we'll also will measure the autonomy you can recover in a quick 5-minute boost. So, how do we present the score? So all our test plans measuring autonomies are grouped in an autonomy subscore. The charging test plans are grouped in our charging subscore, and we also measure efficiency. So what is efficiency? Efficiency is the efficiency both of charging the phone and using the phone. So efficiency of a charge is how much energy you need to drain from the wall plug to charge your battery. And the efficiencies in use is all those current drains that we measure. The lower the current drains, the more efficient the device. And this will be an indicator that the device with a given battery size, the more efficient, the more autonomy it will be able to provide. And then those three subscores, autonomy, charging, and efficiency, are combined into a global score. The subscores are weighted. So autonomy accounts for 3 because, only a few years ago, it was very tough with a smartphone to live throughout a full and entire day. So people still have the habit to charge overnight. So the key focus, according to Dxomark and the studies we've had, is on autonomy. So autonomy has the biggest weight of 3 out of 6, and accounts for 50% of the global score. Charging is the second most important criteria, because whatever your charging ritual, it will happen when you're on a business trip or a long weekend or on a special occasion, that you do need to rely on a quick charging experience to be able to continue your journey. So charging has a weight of 2 out of 6, so that accounts for 33% of the total score. And efficiency is a bit specific. It's not exactly measuring a user experience, but it has the weight of 1. For Dxomark, it's still important for many reasons. And first, an efficient device is a device that was built with quality materials. Special care was given to hardware integration, software integration, and it's a kind of indicator of quality. Second, an efficient device provides good autonomy with a smaller battery. So a smaller battery is an immediate benefit to the end user. It means a smaller device, a lighter device, a sexier device. And third, it drains less energy, so it's green, and that's key for us as well. So we present the score, but as I said, in addition to presenting the scores, we also provide direct and straightforward measurements to the end user. So we provide indication in our reviews on the autonomy you can expect when you're a light user with 2.5 hours of screen on per day with your smartphone, when you're a moderate user with 4 hours of screen on time per day, or an intense user with up to 7 hours of screen on time per day. And knowing this, and knowing your habits, this will provide the user with a good indication on the autonomy you can expect. We also provide the time to charge, how much capacity you recover in 30 minutes, how long it takes to charge from 0 to 80%, and how long it takes to fully charge your battery. We also provide those information as marketing assets to promote the good performance of the device in the market. Finally, I'll conclude by a few hints. So milliamp hours are not equal. Well, you have here on screen 3 Xiaomi devices, which all have a 5,000 milliamp hour battery, and all result in different autonomy experience between 56 or 72 hours. Just a small hint that milliamp hours are not relevant in your buying decision. You don't purchase a car based on the capacity of the gas tank. You want to know about the autonomy. So check our reviews to know what you can expect with your next smartphones. And last, of course, everybody is probably familiar with this, but charging speed is not constant over time. Of course, you need to preserve the battery longevity and be nice and gentle with the battery. Yes, faster charging speeds will result in shorter charging times, of course, but in order to know exactly the experience you can expect, we decided to present two metrics: the time it takes to charge from 0 to 80 and the time it takes to fully charge, because it happens sometimes that 80 to full takes almost the same time as from 0 to 80. So for this reason, we also provide those direct, straightforward information to the end user. So thank you very much. That was a quick introduction to our Dxomark battery protocol. And with that, I'll give you the floor back, Peter.
Thanks, Olivier. That was really interesting. And I think looking at the last chart that you showed, very interesting how much variability there is between charging speeds, even within products within the same product family. And I think your second to last chart was also interesting because you reflected there, some of the products from Xiaomi and how they differ even with the same battery capacity, which is a nice segue to then bring in Partha Nayak from Xiaomi. So Partha's going to talk through Xiaomi's focus on batteries and charging performance. So Partha, please let us have your presentation.
Thank you, Peter. Thank you for having me here and giving me this opportunity to talk about the innovations that Xiaomi has been bringing to the market for the consumers. So on this occasion, I'll be talking about the innovations that Xiaomi has brought in with its recent models on fast charging. So I think all of us understand that with the kind of technological innovations that we have, with the kind of powerful processors, with the kind of high refresh rate displays, with all these technological innovations, I think the amount of battery that is required by consumer for using the smartphone has increased a lot. So we have seen us migrating from 2000 mAh batteries to as high as 6000 mAh batteries, or even more in some cases. So even with those larger battery sizes, our consumers need even more power so that their smartphone can last them for the day. Yes, so this brings us to the innovations on the fast charging bit, because now users, when they are using their phones for a longer period of time, they have to recharge their batteries even while they're using their phones. So they're able to notice the kind of speeds that their charging technology is giving them. So in order to bring a holistic experience to our users, to give them an idea about how they can use their phones without having to worry about their battery life, we bring in the 120 watt fast charger. This is the first time anybody has bought a 120 watt fast charger to the country. So this enables users to charge their phone from 0 to 100% in as less as 15 minutes of time. And I'm talking about a 4500 mAh battery, which is large enough to last you a day, or give you a screen on time of about 6 to 7 hours in a device. So what are the innovations that Xiaomi did in order to be able to get a solution which charges the phone so fast? So there are four main things that helped us get this solution to the market. The first one is basically the changes in the battery structure that we did. So we are using a dual cell battery in our device, which is assisted by a graphene sheet. So how the dual cell battery helps us is that it basically divides the 4500 mAh battery into two subcells basically, which can then be charged parallelly. And the graphene sheet basically helps us to improve the conductivity and helps us improve the charging speed of the battery overall. So with this dual battery structure, we also introduced the dual charge pump so that both the batteries can be charged in parallel. Other than that, I think for batteries, I think the biggest challenge in battery charging is basically that after a certain period of time, after the initial period of time, the power that can be sent into the battery keeps on decreasing as the battery nears completion of charging. So what we at Xiaomi believe is that we monitor that temperature and the kind of power that you are sending into the battery very closely, so that with our Mi fast charge technology, basically we extend the duration for which larger power can be inputted into the batteries. So the fourth innovation that Xiaomi brings in is basically the MTW technology, which is the multi-tab winding technology. So Xiaomi was one of the first OEMs to introduce the dual split or the MMT technology. In that case, we had split the battery into two parts, so that the current has to travel half of the distance as compared to a single anode cathode tab battery. So taking that a notch ahead, we have now the multi-tab winding technology, which basically introduces multiple tabs that are clubbed together in the anode and cathode, so that the amount of distance that the current has to travel reduces drastically. This again improves the thermal behavior of the charging technology and also improves the charging speed. So I'll just maybe give a slight more detail about each of these technologies. So the first one that I talked about is the dual charge pumps and the dual cell batteries. So as I mentioned, the 11i hypercharge, which comes in at a 4500 mAh battery, consists of two cells which are 2250 mAh each. So the 120 watt power that we deliver through our fast charging can simply be divided into 60 watt each, and then is applied into these two batteries in parallel. The second thing that I talked about was the Mi FC technology. So, as you can see, as compared to the normal charging speeds, with the Mi FC technology or the Mi fast charge technology, we are able to increase the sustained level of power into that gets into the battery, which improves the charging time a lot. The final one that I was talking about is the multiple tab windings. So here, instead of having a single tab, which we followed up with a dual tab, now we have multiple tabs. So with these multiple tabs, the we shorten the path of the current that is required to charge the batteries. So all these innovations basically combine together to give users the fast charging experience that we want, so that now even if a user ends up feeling that his battery is getting low, they just have to charge it for a period of 15-20 minutes and they can get 100% of their battery back. And just in order to make this technology available for all our users, I think Xiaomi is one of the few OEMs who provide this 120 watt charger inside the box when we sell the new device. So other than multiple tab windings, I think one most critical part when it comes to battery that people are worried about when we talk about fast charging is the impact on the lifespan of the batteries. So as per the industry standards, I think most of the batteries available in the smartphones currently, they retain only about 60% of their battery capacity after 500 charge cycles. Uh, Whereas the battery that we provide in our 11i and 11i hypercharge, this retains a capacity of about 80% of the battery life even after 800 charges. So 800 charges translates roughly to maybe 2.5 to 3 years of usage. So our customers don't have to worry about the battery capacity going down after a longer period of usage with the fast charging technology. In addition to that, we have multiple checks and balances in our process of charging. So we have more than 30 safety checks across our battery, our charging circuitry, and the charger, which measures the temperature of each and every moment and takes corrective action, so that the kind of power that goes into the battery is controlled and users don't feel any overheating or overcharging. So this system is also certified by TUV Ranland as one of the safest fast charging system that is out there in the industry currently. So that's all about the Xiaomi Hypercharge technology that we have bought in, the 120 watt charger. And just to add a point, I think Xiaomi, when we bring in some new technology to the industry, we make sure that it is available for one and all in the industry. So in continuation to that endeavor, I'm sure most of the people in the industry acknowledge and appreciate that Xiaomi gives the 120-watt charger inside the box, so that whenever the users buy a new device, they have the 120-watt charger with them to experience the kind of fast charging that we are offering to the users. Thank you, Peter. Back to you.
Thanks, Partha. That was really interesting. Now, one of the biggest enablers of fast charging is Qualcomm. They've been working with a number of manufacturers, as I think we will hear in a moment. So Josh is going to give us details around Quick Charge 5 and everything that it offers to their partners. Over to you, Josh.
Thank you for the introduction there, Peter. Yeah, I wanted to talk a little bit today about Quick Charge 5. In 2013, we changed mobile charging quite substantially with the introduction of Quick Charge. In that time, it's become the #1 charging platform in the world. It's by far #1 with over 1,500 certified accessories and more than 300 models of mobile handsets. The newest iteration of this technology is Quick Charge 5. It's the fastest charging platform on Earth, and it's available to handset manufacturers today. So how fast is it? We can charge a 4,500 milliamp hour battery from 0 to 50% in 5 minutes, and 0 to 100% in about 15. We've come a long way since 2013 when we first envisioned the ability to accelerate handset charging over standard USB connectors. With Quick Charge 2, we increased the voltage to safely provide more power than the USB standard accommodated. We were finally able to make use of all that power with the creation of Quick Charge 3. Quick Charge 4 refined those innovations further and added USB PD support for a universal charging platform. Quick Charge 5 represents an order of magnitude faster charging than our original technology. Compared to Quick Charge 4, Quick Charge 5 reduces skin temperature of the phone by 10 degrees Celsius, improves the efficiency by 70%, or can charge 4 times as fast. A big part of the innovation in Quick Charge 5 takes place in the battery. Traditional smartphone batteries use a single lithium-ion pack at about 4.5 volts. With Quick Charge 5, we use 2 of these packs in series at twice the voltage. Increasing the voltage allows us to keep the current, and thus temperature, at a more manageable level. This doubles power delivered to the battery. Managing all this power is a new generation of Qualcomm PMICs. The real power behind Quick Charge 5 is the SMB1396 family of battery charging ICs. The SMB1396 and its sister device, the SMB1398, are divided by 2 charge pumps that support 20-volt input operation, allowing them to charge both 1S and 2S batteries. We take roughly twice the battery voltage from the adapter and divide it in half, while doubling the current to drive more than 10 amps into the battery. They can be ganged together into a dual or triple charge configuration for Quick Charge 5, and they spread the love from ultra-fast wired charging to wireless charging as well. With the increase in battery voltage, we need to increase the voltage of the adapter too. Quick Charge 5 accessories are required to support 20-volt output. They support standard 3 amp and 5 amp current limits of USB-C, but also make accommodations for more current. They support backwards compatibility to USB PD, QC2, QC3, and QC4, and we mandate thermal protection as part of the certification program. Unlike QC4, QC5 can be implemented over a variety of connectors. New to Quick Charge 5 is Smart Identification of Adapter Capabilities, or SIAC. Power adapters are not always completely honest when reporting over USB PD. Snapdragon platforms going forward will take the information provided with a grain of salt. We monitor the behavior of the adapter to determine its true voltage, current, and thermal limits. On the handset side, we have 17 levels of voltage, current, and thermal protection, as well as others built into the chipset. Safety is a top priority of this system. With this much power available, safety is a critical concern. I know many wonder about compatibility, so here's a handy little table. Of course, Quick Charge 5 handsets charge at their greatest capability with a Quick Charge 5 accessory, but you still get great experiences with the older versions of Quick Charge. A Quick Charge 4 adapter will charge a Quick Charge 5 device about as fast as you'd expect from Quick Charge 4, and the same is true of Quick Charge 2 and Quick Charge 3. Of course, Quick Charge 5 accessories like Quick Charge 4 accessories are compatible with USB PD. So you can fast charge those devices to the maximum of their capability, and that includes the iPhone. And that's Quick Charge 5. SIAC for added safety, proven technologies like battery saver for cycle life extension, 2S battery support, next generation of dual charge ICs, more than 100 watts delivered to the battery, unparalleled charge times, and radical improvements in temperature and efficiency. Thank you.
Thanks, Josh. That was great. And now to our final speaker, and that's Craig Weisch. Craig is from Sila. Sila is a company that's developing some new chemistries for the battery market, which is going to potentially change the way that smartphones and other connected devices work. So, Craig, over to you.
Great. Thanks, Peter. Much appreciated. Give me a second here. I'm just loading the presentation. And yeah, nice to speak with you all today, and looking forward to talking about how improvements in batteries are driving the next generation of innovation in smartphones. So in the history of rechargeable batteries, there have been 4 types of chemistries. And at Sila, we've delivered the 5th, which is conversion lithium-ion. And we've delivered that in the market in 2021 with Whoop. And so Whoop launched their 4.0 product. You can see pictures of it here on the slide. The key things here is what they were able to do with a dramatically better battery. And what they were able to do was add features, things like pulse ox and skin temperature sensors, and make a much slimmer profile device while maintaining the 5-day battery life that they needed to have in the product. So this is the sort of innovation that we're working with phone makers now to bring in the phone world. So inside a smartphone, the battery is a very large component. It takes up about half the space. It accounts for about half the weight, but it's actually only about 1% of the cost, of the materials cost of the phone. So as you improve the battery, then you can improve all the things that matter about the phone to the consumer. Things like fast charge, better cameras, form factor, while keeping the battery life that you need to have in the phone. So I mentioned a minute or so ago about the previous generation of lithium-ion. And so what you see here is on the left is cost, and on the right is performance of lithium-ion batteries since 1991, when they were introduced by Sony. And you can see the performance dramatically increased in those first many years, and the cost came down. But that started to level off, and has pretty much leveled off now. And so you're not seeing much improvement anymore from that chemistry. It's really reached its theoretical limit. And so what you see on the right-hand side of the screen, the orange bars above the gray bars, the orange bars represent the improvement by moving to a new chemistry, which is what we're doing at Sila. And you can see quite dramatic improvement there. Our other big market is in electric vehicles, and I just wanted to touch on this for a second. It is somewhat similar in the sense that the performance of the car is very much based on the battery, and that performance of the battery is really based on the chemistry. Now in cars, it's slightly different attributes. There's more things like range and acceleration. Fast charge is also important there. So what's different about Sila than other things you might have seen or heard of? The first is that we're in the market today, improving battery energy density today by about 20%. And as we continue to improve and introduce new products, we will continue to increase that up to 40% and even higher. In the case of the Whoop product, they saw about 17% increase in energy density. The second component is that our materials drop in to the existing battery factories. So no changes to the factories, same kinds of mixers and coaters and so on to replace graphite with a silicon-based material. And then the third piece is that the powders that we make, the silicon anode powders, are designed to be manufacturable economically at very large scale. If you want to make a meaningful impact into big markets like phones and automotive, you have to do things like, you can only use global commodity precursors and bulk manufacturing techniques. Our major partnerships in the auto world, our big public partnerships are with Mercedes-Benz and BMW. In the consumer side, in addition to Whoop that I mentioned, we also have a close relationship with ATL that I imagine most folks on this webinar know of. ATL is the dominant supplier of battery cells to the smartphone industry. A little bit about our investors. So we're scaling up to be a very large-scale material supplier to the consumer electronics and automotive electric vehicle industries. And so what you see here are our investors, including sort of our original investors, more from the venture world. So our original investors were Sutter Hill and Matrix, and then joined by folks like Bessemer. So and then over time, as we retired the technical risk and came to market, we've added larger scale investors. So you see CPP Investments, that's the Canadian pension fund, Coatue and T. Rowe Price, large institutional investors who are looking to fund, factory expansions around the world for products that, have major offtake into big markets like consumer electronics and automotive. So coming back around to phones, where are we today and what happens next? So where we are is that we've demonstrated that cells made with our silicon anode material have gone all the way into the market through all the qualification tests. So not just performance, but also safety and all the things you have to do in order to go out into the market. And where we're focused today is on working with phone makers, figuring out what are the phones that they want to make, what can they do with these better batteries, and helping them make those new devices, come to the market over the next few years. Thanks very much.
Excellent, thanks, Craig, and great to hear what your company is doing there in terms of driving some new innovations in this key area. So let's get into a bit more of a discussion with the panelists around the topics that they've raised. So let me start by throwing a question to Olivier Simon. Now, Olivier, in your presentation, there seemed to be a lot of variability between battery autonomy and battery charging. So in terms of battery autonomy, although there's some variability in efficiency of products, we can see a fairly kind of consistent degradation in battery capacity over a period of hours, but charging seems to be much more variable. Can you explain why that is?
Well, yes, sure. So indeed, you're right, Peter. I think autonomy is less challenged than it used to be only a few years ago. Actually, for the past 3-4 years, battery capacity has increased quite significantly from maybe average 3,000 milliamp hour to now an average of 5,000. The chipsets are now better and more efficient. Even the OS have improved. And the introduction of 5G was not a burden on the autonomy. It's the introduction with smart algorithms was smooth and having not such a toll on battery and autonomy. Of course, smartphones still continue to bring in more pixels, higher refresh rates and brightness, and always more apps. We're always more connected and consuming more data. But you're right, autonomy is less challenged than it used to be. So definitely, you're right. Most innovations nowadays are coming with the faster and faster charging speeds and the race for watts. This wild race is brought with proprietary protocols on top of the standards of USB power delivery. And we now see more and more 120 watt charger device coming in the ultra premium segments, and down to the high end. 60 watts is also democratized. We also see more focus now on battery saving modes and best practices with optimized charging speeds and time. For example, when you are plugging your phone overnight, some dedicated intelligence inside the device will make sure that the battery only reaches 100% right before your wake-up call, so it preserves the battery longevity. So yeah, most innovation nowadays come with charging speeds, but we need to watch out because there are areas where regulations tend to impose the standards for charging speed. So that could maybe change the game in the next months or years.
Okay, thanks, Olivier. And then maybe one further question to push that a little bit further. Can we make any sort of generalizations about how we should think about battery autonomy and battery charging? I mean, is it the case that the best performers tend to have larger batteries, and is fast charging confined principally to the higher end products?
So yeah, it's of course bigger batteries will lead to better autonomy, but not always, because platforms are different, have different efficiencies. So we measure big gaps. I think we have about 20 different devices which all have a 5,000 milliamp hour battery in our database of measurement, and the autonomy you can expect with those 5,000 milliamp hour batteries range from 36 to 84 hours. So there's still a huge discrepancy and a huge disparities, right, of autonomies you can expect on the same battery capacity. For the charging speeds, yes, again, this is correct. Higher the speed and faster it will take to charge your battery. But what's interesting is now the measurement that we highlight, giving the amount of autonomy you can recover in just a quick 5-minute boost. Some devices already allow within 5 minutes to recover 10 hours of autonomy or more even, which is actually extremely convenient. So the habits are changing now. People, I think, are more conscious on the good practice to ensure the longevity of their battery, trying not to plug the device for too many hours, and these fast charging are also changing the habits of users. It's better not charging overnight because it's not so nice for the battery. It's quite good if to try and keep your battery in its comfort zone, which is usually between 20 and 80% of its capacity, and have occasional top-ups to keep your battery above, within this range. And this is of course extremely beneficial for the longevity of the battery, which are quite expanded now. Used to be around 800 cycles. 1000 is becoming the norm, and there are also some announcements with even better longevity. It's still the number one reason why end users have to change their device. And so causing a waste of natural resource, a waste of energy. So the trend is extremely good and looking very promising.
Okay, thanks, Olivier. And now putting a question to Partha Nayak from Xiaomi. So Partha, looking at the latest developments for the 11i hypercharge capability, it's clear that Xiaomi is putting a lot of emphasis on fast charging as a critical differentiator and kind of key feature of your products. You know, from an OEM's point of view, from a manufacturer's point of view, there's clearly a balance to be struck between delivering this sort of new technology and managing cost. So can you give us some insights into how you manage that decision to, you know, how you position that to the right segment?
Thanks, Peter. I think that's an excellent question. So I think as a OEM, as a brand that has millions of users in India, I think the biggest strength that Xiaomi has is that we understand the user requirement in each and every segment that we operate in. We have phones which start at, let's say, $100 and go up to as high as $1,000. So we have a huge range of target segments. We have a lot of customers that we target. Having said that, fast charging currently, especially after the longer period of usage of smartphones, given the work from home situation, given the pandemic, what we have figured out is that faster charging is something which most of our consumers are aspiring to have. And when I say they want faster charging, I mean they want faster charging right at the $100 price segment to as high as the $1,000 price segment. So as an OEM, obviously it is easier for us to introduce these cutting edge technology for our premium and mid premium segment and the flagship segments. So there maybe the cost of such innovations would be maybe less than 10 to 15% of the overall cost, and our users are ready to pay those kind of prices in order to enjoy this sweet piece of technology. As you rightly said, that we need to balance the cost and the targeting of the right segment. So we have introduced the Mi 11i Hypercharge and the Xiaomi 11T Pro, which are premium or flagship level phones, and we definitely look forward to bringing the faster charging technology to the lower segment phones as well. We might not bring the 120 watt charger to all the price segments because that would be unrealistic, and maybe our users will prefer other features more. So we are looking out for the response, having seen that people have really appreciated the Xiaomi 11i Hypercharge and 11T Pro charging solution. I'm sure we'll be able to bring in faster charging solutions to our other portfolio as well.
Okay, thanks. And you know, maybe just trying to unpick that a little bit further. You know, Xiaomi is well known for having addressing a wide range of market segments. So where does fast charging fit into that portfolio? You know, versus just providing perhaps larger batteries, for example.
Yeah, so on our efforts on power management, I think we at Xiaomi understand that we have a variety of users who use their phones differently. Some are power users who basically understand how to optimize their phones in order to save battery for those critical moments. But a large part of our users, they are not tech savvy, and they basically depend on the OEMs to optimize the power management. So in order to do that, we at Xiaomi, we kind of understand the behavior of the users, what kind of apps do they use, for how long do they use it, what can be done in order to improve the battery life of each and every usage that they make, while not impacting the user experience. So let me give you an example. For example, if when we introduce the high refresh rate displays, so the high refresh rate displays basically consumed a lot of power. So in order to avoid the power from draining so fast, what we did was we understood the kind of scenarios that the users are using the display on. For example, if you are using the display to just read a text, then you don't need a high refresh rate. So there we have adaptively changed the display refresh rate so that so that the display can operate at, let's say, 30 fps kind of a thing. So the user experience is not impacted, and at the same time the battery life is also extended. So these are some of those optimizations that we do at various levels in order to increase the power management on the devices. And currently, I think for our normal users, for majority of our users, maybe 85% of our users, the power management that we do works extremely well, and the users are able to use their phone easily for a day, sometimes more than a day, but yeah, easily. So for a day, the users are able to use their phones. Having said that, in order to increase the battery capacity, and in order to give the users a more holistic experience, again we focus on things like quick charging and fast charging, so that even if the users have to recharge their phone, they don't have to spend more time doing the same. So I think all of these will definitely help in giving a holistic experience to the user.
Okay, thanks very much, Partha. Let me bring Qualcomm into the discussion. A couple of questions for Josh. So Josh, Qualcomm is a huge enabler of fast charging, and you work, as you pointed out in your presentation, with a huge number of different manufacturing partners. Working with so many OEMs, can you share any insights into the landscape around the implementation of different aspects of fast charging for different manufacturing partners?
Yeah, the last few years have seen a bit of an arms race in fast charging. OEMs are competing for ever higher charge powers. What seemed nearly impossible only a year or two ago has become basically table stakes, especially in the higher tiers. That's why we build our charging solution to scale up with customer expectations. There's a fully integrated capability at kind of a base level in the chipset that is industry leading. But then we have an additional series of devices that can be added onto those to increase the power at ever higher levels, up above 100 watts. We build the entire smartphone platform into an actual smartphone to fully validate all of these solutions, just like our customers would. We test everything from hardware to software so that the platform is completely safe, reliable, and can perform to the levels that we expect. For customers trying to really push the boundaries of what can be done on smartphones, from a charging perspective, every aspect of the system needs to be optimized. When you're talking about more than 100 watts charging, the connectors, the PCB traces, the flex cables, sense resistors, and the battery itself all become sources of loss. And loss means heat. And heat's the biggest limitation between being able to charge faster. That's why we work with OEMs on their schematics, third-party part selection, layout, in addition to our ICs, as well as providing a fully functional software stack to make it all work together. Everything must be optimized in partnership between us and the OEMs to achieve these kinds of performance levels.
And then before I bring Craig from Sila into the discussion, how compatible is quick charge with new battery chemistries like the one that Sila is developing here?
We work quite a bit with the battery vendors to understand their roadmaps and make sure we're planning ahead of time to intersect. Chipset planning is a 2 to 3 year project out ahead of when consumers actually see the device in the smartphone. So we have to be planning out at least that far with an eye on what the batteries are going to be available at that time. We've been engineering quick charge with an eye on next generation of battery technologies for quite some time, and we can fully utilize all of their capabilities once those batteries are available. At the same time, we strive to maintain backwards compatibility to previous versions of the technology whenever possible. We have a table explaining what consumers can expect in terms of performance from the different versions of quick charge on our website at qualcomm.com/quickcharge.
Okay, thanks, Josh. And last couple of questions to Craig from Sila. So from your presentation, it looks like Sila has essentially all of the elements of a disruptive technology on your hands that you're bringing to market. Smaller size, greater efficiency, no real need to change manufacturing processes substantially. So, we're seeing the first products from Sila coming into some of the wearable technologies. You mentioned the Whoop wearable device, and you showed some pictures of smartphone devices. But how quickly before we see Sila-enabled batteries, more broadly in the smartphone market?
Sure. Thanks, Peter. So we're engaged today with battery manufacturers and smartphone makers. Typically, a new phone design is somewhere in the sort of 2-year range. So that's the process that we're in, both qualifying the battery cell and also working closely with the phone manufacturer to make sure that everything's sort of lined up on the phone side for the new product.
And so if we take that further, so what does the battery experience, what's it like with the Sila-enabled battery in your smartphone?
Yeah, sure. So what it looks like to the consumer is better, and it's much more than a better battery experience, right? Or what a user might think of as a battery experience. As a user, you experience the product, and so what you're seeing in a phone is maybe it's better cameras or faster network or better form factor, and then you have sort of maybe a baseline threshold. You can't compromise the battery life dramatically to get that slightly better camera. That's not a win, for anyone. So that's the big thing I think that the user will experience. And something else I'd introduce here. So our materials increase the energy density of the batteries, right? How much energy you can store in a given space or weight. And you can think of that energy density as a sort of currency that you can spend. And so one way you can spend it is, put more energy in the same size battery or put the same energy in a smaller battery. And those are really valuable things. Other things you can do with that energy density is you can keep everything else the same and improve something else like fast charge. And so these are the sorts of trade-offs that we work with the phone makers and the battery makers to understand what's going to be most valuable in the product. And so, what should we engineer towards?
All right. Thanks very much, Craig. And that actually brings us to the end of this webinar. So it just remains for me to thank our panelists, Craig Weisch from Sila, Partha Nayak from Xiaomi, Josh Warner from Qualcomm, and Olivier Simon from Dxomark. Hope you found that interesting. I think there were some very illuminating insights there into the battery technology. And please do check out our other webinars on our website, and we have quite a large back catalogue of podcasts that you can also enjoy. And we look forward to seeing you on the next Counterpoint webinar. Thank you.